Well, you know who it is by now, and you know the deal. We're on the third installment of this. This unit circle stuff, it could go on and on and on and on, but this is, for our intents and purposes, to get us up through that test that's coming up. This is it. This is the final installment for that. There might be a continuation of this up on my YouTube channel, but today, what we're going to do is we're going to talk about the tangents. Now, remember for the test, you want all the angle measures in degrees and in pi radians. So that's 17 points and 17 points. And then we want the coordinates at the poles, and that's 8 points. And we want the other coordinates, and that's 24 points. And that's what we did in that second installment. So if you keep a running total here, cumulative total, that's 34, that's 42. That's 66. The last page, even though it says page 5, it's a typo. The last page, remember, it's got 6 questions. It's got some questions at 3 points each. So that's another 18 points. So that puts us at 84, which means then for the tangents, it's 16% of the test. 16% of the test is based on the tangents. So let's go back to when we first started talking about right triangle trig. I did mention the fact that the sine is the opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse. So if we were to take the sine over the cosine, making some substitutions, that's the opposite over the hypotenuse, over the adjacent over the hypotenuse, and so that's going to be the opposite over the hypotenuse times the hypotenuse over the adjacent, and the hypotenuses ended up canceling, and it's the opposite over the adjacent, which, if you remember, we said that the tangent can be written as the sine over the cosine. So, reiterating what we said the other day, we said the sine is the y-coordinate, the hypotenuse is the radius of a unit circle, which is 1, so the sine is the y. Cosine is the x-coordinate over 1, which is just the x. So the sine is the y, the cosine is the x. So again, making substitutions then, what the tangent's going to be would be y over x. Well, that's pretty easy because we're going to know the coordinates at each thing. Well, yeah, you're right, it is. So to find the tangents, I don't know the structure of the test, but it's kind of interesting. To find the tangents, you might actually want to kind of refer back to your coordinates page. To your coordinates pages, I should say. So let's just take a look at one coordinate and figure this out then. So this coordinate, remember the center is 0, 0. This first coordinate at 0 degrees or 360 degrees, or 0 pi, and at 2 pi. So the coordinates there are 1, 0. Not 0, 1, it's 1, 0, because you're moving one horizontal unit along the x-axis. So if we had to find the tangent then, what we're saying here is the tangent of 0 degrees, or the tangent of 360 degrees, or the tangent of 0 pi, or the tangent of 2 pi. All those are equal to, remember we said the tangent is sine over cosine, y over x. Here's my x, here's my y, so it's 0 divided by 1, which simplifies to be 0. Okay, so again with our TI calculator, remember our Inspire is set up by default for radians. So let's go with the tangent of 2 pi. And I could just type in tan of 2 pi. And there it is, it's 0. Okay, tangent of 0 pi, 0. Well, there we go. Let's go across the way. Let's go from the east to the west. Remember the coordinates here are -1, 0. So the tangent at pi would be y over x, 0 over -1, which is still 0. So the tangent at pi, not 2 pi, but at 1 pi, is 0. Well, that's interesting. So anytime if you've ever worked on timing on an older engine, you understand what it means to be 180 out. The concept of 180 out comes into play here. What are you talking about 180 out? I'm talking about across the way, from east to west, or from north to south. Anytime you're 180 out, anytime you're 180 out, what are you talking about 180 out? So, North Pole to South Pole. Anytime you're 180 out. So, from pi over 4 to 5 pi over 4. Anytime you're 180 out. So, from 3 pi over 4 to 7 pi over 4. Anytime you're 180 out, the cool thing about the tangents, if you haven't noticed this yet, they match up. The tangents are identical 180 out. Tangents that are 180 out, they're identical. So your strategy for filling in tangents might be a little bit different. So let's go up north. Up north, remember the coordinates, we didn't move along the x-axis, so it's 0, 1. Okay. So my unit circle here is kind of getting to be a mess. So let me start with a clean slate here. Okay. So again, at the North Pole, the coordinates are 0, 1. The tangent at pi over 2, remember that's pi over 2 in terms of radians. The tangent there is y over x. Here's x, here's y. So it's 1 divided by 0. Now, hopefully you remember from early on in the year and from chapter 2 when we studied vertical lines and their slopes, what happens when you divide by 0? 1 divided by 0 is undef. It's undefined. So this is undef. So the tangent at pi over 2 should be the same. It should be undef. The tangent at pi over 2 is undef. Okay. Remember we talked about being 180 out, so let's go to the South Pole. 0, -1. That's going to be 3 pi over 2. So the tangent at 3 pi over 2 is, here's x, here's y. It's y over x, so -1 divided by 0 should be undef again. Check it out. Tangent of 3 pi over 2. Let me just squeeze a 3 in there. And it's undef again. So just to reiterate the tangents, anytime you're 180 out, the tangents are the same. 180 out, across the way, North Pole to South Pole, East Pole to West Pole. Anytime you're 180 out, the tangents are the same. And you might say, well, does that work elsewhere? Well, let's find out. Let's find out. Okay, so we'll lock this in place. Remember, I like to call these the quarters or the corners. Corners, it kind of rhymes. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Remember the coordinates here are rad 2 over 2, rad 2 over 2. They're the same because of the isosceles, right triangle for the reference angle. Okay. It's kind of weird when you draw this like so. Some people call these like the bow tie angles. I've seen some videos that refer to them that way. Kind of looks like a bow tie if you were to shade that in. Okay. But anyways, so these coordinates, remember in quadrant 2 it's negative, so rad 2 over 2 and rad 2 over 2. And then third quadrant, negative rad 2 over 2, negative rad 2 over 2. And then again, this other coordinate, rad 2 over 2 and negative rad 2 over 2. Okay, so let's just look 180 out. Let's look at the ones 180 out from each other, and let's find those tangents. So the tangent of pi over 4, remember tangent is y over x. Y over x. So here's x, here's y. So it's rad 2 over 2 over rad 2 over 2, and something divided by itself is 1. You say, but look at all those negative signs down at 5 pi over 4. When we go there, it's going to be different. Is it? Tangent of 5 pi over 4 is negative rad 2 over negative rad 2 over 2. Something divided by itself is 1. And again, those tangents 180 degrees out from each other are the same. It's 1 and 1. So what happens if we go down to 7 pi over 4? Tangent of 7 pi over 4 is y over x. X, y, so it's negative rad 2 over rad 2 over 2. And what that's going to be then is a negative divided by a positive, the same thing, so it's negative 1. So that's negative 1. Now let's go 180 out from that. 180 out from that. So the tangent at 3 pi over 4. Here's x, here's y, so it's y rad 2 over 2. Over x over negative rad 2 over 2. So it's a positive divided by a negative, the same thing, and it's negative 1. And again, 180 out, we have the exact same values for the tangents. So this is true, this works all the time. Anytime the tangents are 180 out from each other, they're going to be the same. Let's go to the thirds. And I will kind of go nice and slow through this because I know there's still some skeptics that are like, that doesn't work, that 180 out thing, it's not going to work on the thirds. Surely it's not going to work on the thirds. Well, don't call me Shirley, and it is going to work on the thirds. Check it out. So we've got this 4 and this 5 pi over 3 down here. Coordinates. Remember, you might not know those coordinates. Sketch that reference triangle. That reference triangle goes like this. So we're comparing this horizontal distance. This horizontal distance, that's not as far as that vertical distance. So the horizontal distance is the x, and that's the 1/2. Remember, that's across from that. So anyway, that's a half. So it's 1/2 rad 3 over 2. Quadrant 2, it's going to be negative 1/2, positive rad 3 over 2. Quadrant 3, it's negative and negative, so negative 1/2, negative rad 3 over 2. And then we get positive 1/2 and negative rad 3 over 2. So the tangent of pi over 3 is y over x, rad 3 over 2 over 1/2, which is rad 3 over 2 times 2 over 1. The 2's cancel, and it's just rad 3. Just rad 3. Boy, there's all these different things to memorize. Well, yeah, there are a lot of different things to memorize. You're right. 180 out, is it going to be the same thing? Is it going to be the same thing? Well, let's see what happens. The tangent at 4 pi over 3. Y over x. Negative rad 3 over 2 divided by negative 1/2. It's negative rad 3 over 2 times negative 2 over 1. The 2's cancel. The negatives cancel, and it's rad 3. Hey, it was rad 3 up there. It's rad 3 down there. So it is rad 3 down there. Huh. 180 out. It's the same. Yeah, it is. That works every time. Trust me. Okay. So hopefully by now you get the idea what's going to happen here at the thirds then. Well, let's look what happened before. We had 1 and negative 1 for the quarters. For the thirds, it's going to be the same thing. It's going to be rad 3, and then negative rad 3, and then negative rad 3 down here. Okay? Maybe you see an easy way to memorize the tangents at the thirds. Maybe. If not, after we get the sixths down, you'll see. So here's the sixths. And with the sixths, so as to not clutter this all up, I'm not going to go through all the calculations involved. I'll just go through the first one at pi over 6. Now remember, we do have 5 pi over 6. And then we're also going to have 7 and 11 pi over 6. Okay. So the coordinates here, this x distance is greater than the y distance. So the coordinates are rad 3 over 2 and 1/2. So the tangent at pi over 6 is 1/2 over rad 3 over 2. So that's 1/2 times 2 over rad 3. Hopefully you remember what happens here. So this is 1 over rad 3, and we need to rationalize it. It's rad 3 over 3. Okay? It ends up being rad 3 over 3. Remember, 180 out, it's going to be the same. So the tangent, rad 3 over 3, 180 out, across the way. Oh, might help if I draw that in the right place. 180 out, rad 3 over 3, rad 3 over 3. And then remember, by the SIGNS, what's going to happen here is the signs here are just going to be negative, so it's going to be negative rad 3 over 3 and negative rad 3 over 3. So you might think, well, you had a clever way for the coordinates. Do you have a clever way for this? Well, for me, if I think of the word 6, I think of different ways to arrive at 6. Those of you that play that 2048, you might think numerically. 6 is 3 plus 3. Hey, a 3. Oh! And a third just has a 3 in it. So here's the thing. Here's little tricks that I kind of use. Thirds, the tangents are going to be a rad 3, either plus or minus. For the sixths, the tangents are going to be plus or minus a rad 3 over 3. And then the poles and the halves, you got to kind of fend for yourself on those. I really don't have. Maybe for the poles, isn't it 0 for the tangent at the poles? So at the poles, the tangent is 0. But that's at the east and the west pole. So that doesn't really help with the north and the south, does it? So maybe that's not the best idea, because sometimes the pole is it's undefined at the north and south pole. Okay. Wait a minute. What about this? Upper, under. The tangent is und, and the tangent is und. So maybe that'll help you. Maybe, I don't know. So let's look at all the tangents, all in one shot. And then we'll look at the whole thing. So here we go. So the tangents, 0, 0, und, 1, 1. Remember, 180 out, they're the same. And then across the way, the signs, SIGNS, the signs are the opposite. So -1, -1. And then if I think, well, this is a third. So at a third, it's going to be rad 3, 180 out. 180 out is also rad 3. At my other third, it's going to be negative rad 3. Again, 180 out. 180 out puts me at negative rad 3. And then at the sixth, it's going to be rad 3 over 3. 180 out. That's what, 7 pi over 6 there, right? 7 pi over 6. So that's going to be rad 3 over 3 as well. And then, again, at a sixth, at this 5 pi over 6, remember the sign, SIGN, is going to change, so it's going to be negative rad 3 over 3. And again, 180 out is going to be negative rad 3 over 3. So that's it. That's the tangents. At the thirds, they're rad 3 or negative rad 3. At the sixths, they're rad 3 over 3. Across the way on the poles, they're 0 and 0. North and south pole, they're undefined. And at the 45 reference angles, or the pi over 4s, they're 1, because the sine and the cosine are the same. So from the top then, here we go. Let's see if we can't fill in this, this unit circle test. From the top. I'm going to use my calligraphy pen here. I know the print here is going to be kind of small. Apologize for that, but so you're going to know the whole test before you even see it. So angle measure in degrees, 0, 360. And on the test, you don't need to put the little degree symbol because it says angles in degrees. So then we got 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, the 330, and that's page 1, and that's 17 out of 17 points. There we go. God. Moving on to the angle measures in pi radians. 0 pi, 2 pi. On the 0 pi, if you don't include the pi, it's okay if you just write 0. Okay. Now it says pi radians. I would like you to write pi on these. So we've got pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. We've got pi over 4. We've got almost put that in the wrong box there. 3 pi over 4. We've got 5 pi over 4. 7 pi over 4. Figuring out a strategy, that's the tricky part on this, okay? And we've got pi over 3, 2 pi over 3, 4 pi over 3. That's the one that always tricks people up. 5 pi over 3. And then, of course, the pi over 2 and the 3 pi over 2. Okay? So there's 17 out of 17 points. That's that. Okay? Again, strategy. Oh, I forgot one. Oh, that was 16 out of 17. I forgot pi. How could I forget pi? So that's that. Moving on, the coordinates at the poles. Remember, it should be an easy 8 out of 8, but every time somebody messes it up, keep in mind the center's the origin. If I go over 1 unit on the x-axis, I'm at 1, 0. Take that time. Think about that. If I go the other way, it's negative 1, 0. 0, 1, 0, negative 1. Okay, so there's my 8 out of 8 points there. Okay. Moving right along, the other coordinates. Remember, everything's over 2. Take your time with this. It's over 2, 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 it's over 2. The x's are negative, negative over 2, over 2. Negative over 2, over 2. Negative over 2, over 2. Southern hemisphere, remember something different happens down there. But again, I'm going to have negative over 2, negative over 2, negative over 2, negative over 2. Negative over 2, negative over 2. 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 Okay? When I grade these, if I don't see a negative, it's going to be wrong. A sign error, an SIGN error, is a big deal. So make sure that your characters, when you print these out, make sure your characters are legible. I know with the box it's going to be kind of hard to tell on some of them because you'll see in the print. But. Okay, so anyways, on this one it's 1, 2, 3 down, and 1, 2, 3 back up. So we got 1, 2, 3 down, and 1, 2. Now keep in mind, I keep saying 1, 2, and 3. I'm not saying radical. Make sure you have a radical over the 2's and the 3's. Radical 2 and radical 3, okay? Be real clear about that. Okay. Remember, in the southern hemisphere, things kind of change. So in the southern hemisphere, it's rad 3, rad 2, 1 down. So rad 3, rad 2, and 1 back up. And again, in the southern hemisphere, rad 3, rad 2, 1 down, rad 3, rad 2, and 1 back up. Okay. So that's my 24 out of 24 points on those coordinates there. And then the tangents. Remember, at the upper and under, it's und and und. Across the way, it's o, o. And then at the 45s, it's 1. 180 out, it's also 1. 45s, it's 1, but negative when we go to the second and fourth quadrants. At my thirds, actually at my sixes, my sixth, it's going to be rad 3 and 3, because 3 and 3 make 6. And 180 out, 180 out, 180 out, It's going to be rad 3 and 3, the same. So then at my bow tie angles here, remember these things that they look like bow ties. Some people call them bow tie angles because it looks like a bow tie. So I'm going to have negative rad 3 over 3 and negative rad 3 over 3. And so then at the thirds, at the pi over 3, that just leaves rad 3, 180 out, rad 3. Second and fourth quadrants are going to be negative, so negative rad 3, negative rad 3. And that's my 16 out of 16 there. Okay. Finally, the last page, it says page 5, but it's actually page 6. Radius of a unit circle is 1. Center is at 0, 0. Yes, you need the coordinates. Yes, you need the parentheses. The sine is the y. The cosine is the x. So then the tangent would be y over x. And the radius corresponds to the hypotenuse. And there you go. That's it. I hope everyone studies hard. I hope everyone gets this. If there's time left in class, we'll practice, practice, practice. I have hundreds of copies of this. It's been real. It's been fun. Hopefully you do well on the test and don't cheat. Thanks.